Để cho em quay lại cái phần. Ok. Thì đây là cái bảng so sánh là một số cái khác biệt của row oriented với lại columnar oriented. Cái lý do mà Trâm nhấn mạnh cái này tại vì Trâm sợ lúc mà đi thi ấy, nó sẽ hỏi một số cái về Columnar Database là cái phần kiểu gì mà nếu mà nó hỏi về NoSQL thì nó sẽ dễ hỏi cái phần này, kiểu như là những cái mà về acid rồi là cái cách mà acid với lại base model và cái cách mà nó read với write đó. Ủa chết cha, chờ chăm chút nha.
Okay.
Thì là những cái mà về mà acid model read write, cái cách mà nó store trong memory để mà optimize thì dễ là nó sẽ có trong phần này. Oh, hello Steve. Ủa Steve là ai vậy?
I have no idea. Hello, Steve.
Are you Vietnamese or where non-Vietnamese?
No.
Sorry, because right now we just have Brian who is Vietnamese, so we are conducting the course in the English. I mean in Vietnamese, but let us know if you are non-Vietnamese. Then we are happy to speak English. So basically, now we just go through some difference between row-oriented and columnar-oriented because it's related to the concept of database. So that's what we. Oh, okay. So let's switch to English, Brian. So Steve can understand and join us. Okay. So these are the difference between row-oriented and columnar-oriented, and you can read more in the zone article where I get mainly the information from. And it's important for the exam because in the exams they will ask on this fundamental knowledge on like the data. You need to remember the format of the database to answer the scenario questions, and I'll go in depth further into these concepts in the later sessions and how it related to Azure database. For now, we will just go briefly on some basic knowledge of what a data engineer needs because these skills could be transferable and it will be the same in any cloud that this knowledge is required for a data engineer. So Steve, previous in the previous class, we discussed a little bit on the data warehouse and data lake, data mesh, and data mesh. They won't give it to the exam, but I think it's still really good to know of what we are transiting to, and little bit about OLAP and OLTP. So today we talk about row and columnar oriented, the difference of it, and relational database key term, and that we will finish with the relational database, and we will start to move to distributed system. And in the different cap theorem and consistency and Spark. And in the next session, we will talk a little bit about different security method and also NoSQL. So my plan for this class is that we will have 3 sessions to like go overview of some basic fundamental knowledge in data engineer, and then in the 4th session, then we start going to the Azure system and learn about Azure architectures and things like that, and different method that's specific for Azure, because the way why we divide the sessions like that will help us a lot in the apply and have a transferable skill that we can use later on in the other cloud platform. So let's go back to our some main topics today. So we just go through this row oriented and column oriented. I think you guys got this one right. then I can move on to the relational database key term and reviews, and we can go to distributed. So let's go to this relational database. I wrote this. I think Brian, you have seen this. So Brian, do you have any questions on this? So this is in the relational database. Let me talk a little bit about relational database. Uh, Brian and Steve, how familiar you guys with the relational database concept?
Actually, I have experience working with database, but sometimes some uh, terms that I really don't have much familiar with,
Mm.
like ACID.
Oh,
Can you
okay,
talk a little bit more
sure,
about that?
sure. Let me go over that. It's a good question. I actually wrote an article on that. Let me just go over it and see. Don't worry, if some concept I talk too fast, then there will be a recording. You guys can reach me anytime on the Slack. So okay, so let me talk a little bit about the difference between acid and base. So it's just a concept, you it's alright if you don't know because they're not gonna test you on this specific idea, but that is good to know because when you work with relational and non-relational database, then you guys can kind of see about the concept. So this concept though it will be tested on DP 300. No, sorry, DP 900. I did see that on the material on DP 900, but it won't be tested on DP 200 because they assume that these are the fundamental knowledge and you should know it. So they won't have tests on that. But I just highlight out because I want to everyone to have the same level of knowledge before we start on the Azure. So basically, you guys know right now, by now that we have non-relational and relational database. So relational database, they build on the ACID concept, and the non-relational database, they build on the base concept. Can you guys see the picture here? Let me zoom it to
Okay.
So a relational database is known for its perform inconsistency, and by that, it's a good. It apply the acid base for the as a gold standard. So let me see if I explain the acid in here. No, okay, that's my part in here. My bad in here. So basically, just what acid does is talk about like how your data have to be like consistent and consistent by creating different rules in the to restrict your data in the same format, and how it have to be isolated and be away from different resource. So let me put it up. We just want to ASIC database for right now. We don't want, okay. Okay, can you see the screen, the Brian? So
Yes, yes.
yes, so basically it's the method to construct a database. So you need consistency to ensure all the data construction. So you can see that what I talk about like rules, constraints, cascade, and triggers. So all of these terms I have layout on the here. So you can ask me later on, or if you have questions, you can ask me now. I'll go quickly through some of the key of the terms. So you can get what? So isolation. So all transactions occur in isolation, and it's also about the data is stored like in the away from one another. So that one value doesn't affect the whole thing. And durability, once the transaction is committed, it remains in the system. So what it does is it more about theory than like actually how you apply it to the system. So like once you are when you are database administration, then these are the things that you need to keep in mind when you design a database, and how you have to apply the properties in the recovery. So that's what it meant. And we will go over the base one in the distributed system, how like we have base model and how we have cap theorem, and how cap theorem affects the model of a distributed system. You are all right there, Brian?
Yes, yes. So
Yes.
it's more, yeah. So this is more about the recovery, data transaction, data transaction oriented recovery.
Uh,
Am I right?
it's about build how you should remember to build the whole database. At it's about the whole picture of building a database. So it's similar like how in Python you have Zen of Python. Have you read this one? This one is actually really interesting, actually. So like how in Python we have a Zen of Python, which is like some of the rules, or some of concept,
Uh,
or some of the good practice on how you should write your code in Python. Then
mm,
yes, so in database we have ACID, which is like how you should construct your database in relational database.
okay. Okay.
Yeah.
I'm okay now. I'm fine now.
Yes. And base, we will talk about it on NoSQL. Yes. Okay. So benefits of this model is that it ensures database integrity. We have like a standard schemas, standard rules throughout the database. So for example, if you because relational database is that it is a schema on write, right? So when you create the database, you write, you create a schema, right? So for that, you define the schema at the time that you create it. So for example, you have different columns, and in those columns, you have to define, for example, like you want a column that have a character, and or like a column that you have string and certain length of the string. For example, you can all define that in the schema and rules. So I just want to talk a little bit about this. So for non-relational database, and for yes, NoSQL is schema on read. So that means like you doesn't care about what you store, what you have in the database, because a lot of times, well, majority of time, that what you have on a Spark system, for example, is like non-relational data. So you don't want to restrict it when you write. You want that when you read the file, you will be define the schema at that point. So that's why it's called schema on read. And a lot of time, if you use Spark, and I will introduce about Spark later on. So if you use Spark, there's an ability to infer the schema. That means that Spark, it will get some random information on the rows of the database, and it will use that symbol to define what type of data it has, and then it will infer it for you. So it will guess it for you and give it for you. The good thing is that you don't have to manually define each of the columns. And but then the bad thing is that because it gets simple, so some simple, it it can be different from the whole data in that columns. So it might be some wrong columns. So you would have to do those columns that the Spark doesn't got right. You have to do it manually. Okay, so let's go over to some of the key terms in the relational database. So relational database, we are very important in different type of keys. So super key, candidate, primary key, foreign key. So go over to that terms and query language. So we have DDL and DML. So DDL is uh, DDL is like what the data analysts use mostly, and DML is for most of the database administration use mostly. So there's a lot of sorry, I got the opposite. So DDL is, hang on,
About the definition of the schema,
hang on, let me.
like to create the schema, how to create it. Yes.
So let me put up DDL example because sometimes when I see the definition here, I got confused as well. So let me show you. Because a database as okay, here we go. So there's a two domain, mainly two domain. There's more, but then let's talk about the main domain. So DML and DTL. So when you a lot of people know SQL, right? Back end guys know it. Data analysts know that, but then the scope is a little bit different. So DML is about like when you get the data, you update the data. So select, insert, update, delete, and DTL is like when you create, you drop the table. So for me, I use a lot of DTL in my work, but for a data analyst, they could use like a lot of DML where they select the data and use different subquery and nest system to query out the information from it. It's not important for the exam, but then I show it there because this is in case you guys want to take the DP 900. So, but then other like different key, like super key, primary key, foreign key, you need to remember that. And this part, it will also help you in the DP 300, which is about relational database. Okay, so schema diagrams. I talk a little bit about schema on read versus schema on write. So you got it, Brian, Steve?
Yes, yes.
Okay, so good, because this is really a key, one of the key difference between the relational and non-relational database. So different type of join. We have equi-join and non-equi-join. So equi-join is the one that you have with the equal sign, So like you can like select a from. Let me show you on here. I think it will be easier. So equi-join where you like find a key that equal that valid in both of the table. So let me see if I can quickly find an example. But you guys know what equi-join is? So when you use left join, right join here, then you use equi-join because you like select a dot employee ID equal b dot employee ID. You guys got
Oh
it?
yeah, yeah, yes. Got the
Okay.
idea.
Okay, so let's go to
So how about non-equi join?
non-equi-join is anything that besides equi-join. So you can select things like when a dot primary ID is not equal for b dot primary ID, or like when a dot primary ID is bigger than b dot primary ID. So
So
basically, Yeah, so basically it's not equal. So you can select ID that outside of the join, so that you can select the ID that like not overlap with one another. So it's
Yeah,
yeah.
yes.
So it's called non-equi join. So equi, remember equi is mean equal.
Mm-hmm.
Yeah. So that is the quick tip to remember that. Okay. Cartesian product is actually appear in one of the Microsoft exam that related to the database, but it's more of the beginning level. They have this term, but so basically that means like in the math, like you remember before when we learned about in the high school where we learn about the math, it like A belong to B or B belong to C, right? So it's basically a Cartesian product is combined from two relations whether the attribute match. So basically like it just means that you select you select the information and join the tuple together when there's a match. For example, you do the cross join and it's match, and then you create a new table that have name and department ID. So that is for Cartesian and different data type. So I just want to highlight that it depends on the database. Some database have additional data type. So if you go to Hive SQL and you see, so Hive is a stack that around Hadoop. So you could, let me see. Okay. So what I write here is some of the basic one that like all of the system they will have this. But then if you go in here and you read, and sometimes you have like, let me see what is some of the example of a different. So you can have like struct and map, which is not usual in other relational database, and those are the different data type that Hive support. And it's a really good idea when you work with a new system and you go into the document to see what is their support data type. And because nowadays we have like Snowflake, in the AWS, and we have Hive and Cosmo DB and other that from Azure. So it's a good practice when you come across a database that you haven't worked with before, then you go in here and check for the data type that they support. Let's have with the data manipulation later on. So another thing that I want to highlight is sometimes we have the type that not support yet in these documents. And what we want to do is we would do UDT, which means user defined type. So we can define a type for our database. And the next time when we write it, we can call out that type of data. And of course, we have datetime and timestamp, which is the format of time that will help us to query out the information. Okay, so some of the questions that sometimes when people test, so this column is sometimes when I write the questions that people go ask in the interviews. It's not really important for the test, but sometimes people ask this in the interview, so I write it down also. So function aggregate versus window. We need to know this for DP 300 specifically because they will ask you to write extensive query in the TSQL. But for this class, I have seen some materials on the Microsoft, and mostly it will just ask on the like select data out. So it won't be like extensive, complex queries. But I just want to highlight on aggregate versus window function, and each of these we have the difference property that you need to be aware of. Okay, this won't be tested, so I will talk when we reach to the DP300. Constraints. So constraints is like when you create a database, then you need to create different constraints so that you ensure the data will be uniform across the whole organization. So because sometimes people type in typo, so that's why it's good to have constraints, so to ensure like all the data could be unique, so all the column with ID will contain ID only. There won't be like name of the person, for example. So privilege, because data, there's certain data you want to grant different permission for people to see, so it's good to have different privilege on this. So like people who can view, who can see, for example, people name and birth date, and there it will be there will be another method in this, for example, hashing, masking, and things like encryption, and I will talk more about this in that session. So there's some advanced concepts in the dynamic SQL UDF, which is user-defined function. So and trigger and recursion. So user-defined function is similar to user-defined type. So that, like, for example, when you want a function that is not exist in SQL, then you can define it, and next time you can call it to help you process with the data. So that's it in the some of the advanced, not advanced, but some of the basic concepts on the relational database. So we have 30 more minutes. So let's quickly go over the distributed system. You guys have any questions so far on this?
It's okay. We
Okay,
can move to distribute the system.
okay, okay. Oh, we have some more people. Oh, hi, Harris. Welcome to the class. Sorry, do you have questions so far, or you are all right? Okay, so let's go on distributed system. Aris, you will see a lot of this already. I'll try to go briefly on some of the concepts that we talk about. But so just so you know, so I will talk on the distributed system and some of the CAP theorem, and I'll talk extensively more on consistency and different models and Hadoop database this time. So Hadoop, HDFS, and hbase this time, and after that I'll talk about Spark, which is the one that you have heard me I think 3 times. Yeah, you are a good participation in all my Spark session. So that is the topic where we have most overlap with your previous session. But I think it will be still useful if you sit through until the at least this one, because this is the new material that I haven't mentioned in the other previous classes. So let's talk a little bit about distributed system. So you probably have learned right now about the vertical scaling, and why in distributed system we need to scale horizontally. So vertical scaling is where like you have one monolithic system, and in order to expand its capabilities, you keep adding more RAM, more CPU, more memory on the existing machine, and there's only a limited on how much RAM and memory you can add in more, because before you have to upgrade it to a bigger and stronger machine. So to scale more, there's a method of distributed system where you don't have to use the most expensive hardware to build your system, and it will expand based on your need. So when you need more, then you can add more, I could say mini machine in there, not mini, but you can add more hardware in there to make it more powerful and fit with your need. And also there's another advantage of distributed system is fault tolerance. So because this machine have a shared state and there's a operate concurrency and can fail independently without affect the whole system uptime. And also about it will help with low latency is where you have like node in different geography location, and it will help with the user that query into the database as fast. Oops, hang on, I have something. Okay, sorry, I'm back. Let's move on to the new one. So in this one, I just want to highlight about the distributed system synchronization. So and I just want to raise out that this material won't be tested, and there's a lot of different method on keeping track of the time in the distributed system. But I want to highlight some of the concept between the logical clock and physical clock, and one of the influential paper that create that create the introduction for logical clock. So when you have a single system, right, processors and all share a common bus, so time isn't much of the concern, and because the entire system share the same understanding of the time, and so it's consistent. However, in a distributed system, it's not the case, because in distributed system, we don't share a common single system. We have multiple systems that connected to one another. So each system has its own timer that drive its clock. So each timer have different characteristic, and the characteristic might change with time and temperature. For example, so over the time, it will drift away from the two different rate. So that's why it's always have been a struggle to keep track of all the event and time. So here I want to mention that event and time is different. Event is like a logical order, like you have event A and you have event B and you have event C. So logical clock highlight in that when the A is supposed to happen before B, and B happen before C, then A happen before C. So this is the part that where I'm talking about. And this is the concept that introduced by Lambert. You guys all right with it so far here?
Yes,
So
yes.
yes, the purpose of logical clock is not necessary to maintain the same time with the real clock, but instead is the way to keep track of informations. So the key idea here is when there's a process of message exchange, right? So message must be sent before it received. So that way we keep the logical clock in order. So now I have sent to Brian some of the Vietnamese videos on the different I believe different algorithm on clock on distributed database, and they mentioned about Lambert too, but then there's some weakness in this algorithm that Lambert didn't mention. For example, in here we just mentioned about logical clock, but without mentioning about like how to keep track of the timestamp and how to get the real time from the event. So here it's just about the event, not the time, and we have more algorithms later on that help us with that. Uh, so the key memory that you need to remember from this slide is that we have different clock algorithm in distributed system, and we don't rely on the physical clock. And keeping track of the struggle of keeping track of the event and the events and timestamp of different system, especially when it comes to replica, is still a replication of data is still a relevant constraint and struggle. So distribution pitfalls. So in distributed pitfall, this is the most common 8 fallacies of distributed computing, and you can go over it. It just I just throw it in there so that you know that a distributed system is wonderful. It addresses so many issues, but then also there are issue with network topology, administrator. That really the constraint of the system and latency too. So let's talk about distributed data store. So we talk a little bit about ACID. So ACID model is focused on consistency and availability, and that's what most relational database always have. So remember, with relational database, there's a very strong consistency in data. So data must be consistent throughout the database, and availability, that means like the data always available for query, for use. So base is a very different concept. So it's the opposite of acid, and it's also in like in real life, how like in chemistry, where you have like acid and base, and they are very opposite and different in polar, right? So base is the opposite spectrum of acid and is mostly used on non-relational database, and it focuses on the partition tolerance and availability. And it's said here the core concept of basic weak consistency is okay, and we will learn about how weak consistency is and how it's all right in a distributed system in the next slides. So in this one, before I go further on the distribution system architecture, I'll talk about CAP theorem, and it's a very, very famous and well-known theorem in the distributed system. So basically, it's highlight you have three properties: availability, consistency, and partition tolerance. And in here it's highlighted that you can only have 2 out of 3. So you cannot have 3. You can build your system in like CA, which is consistency and availability, AP, which is most of the distributed data use, which is availability and partition tolerance. So let's go over the latter a little bit. So consistency, so it's equivalent to have a single update copy of the data, because distributed system we have like data across the nodes, right? So sometimes when one node update, the other node hasn't been updated yet. So this is the property, one of the property of consistency. So have single most update copy of the data. So now to think of that, if you are using Facebook, for example, if you just want to see like your friend pictures, or like you go to Instagram and you see different pictures, really consistency where you need to like see the most single update copy of data, is it really something that you care about? No, right? But then when you are in the bank and you have like transaction where like you transact things from across the globe, for example, you are in Vietnam and you want to make a transaction in the transfer wire money from Vietnam to Australia, for example, then consistency is really something that you need to pay attention for. So depends on the purpose, we will architect a data store that suitable for that purpose. So we go next to the availability. So availability is the data that available for updates, for query, for manipulate on. And we go to this partition tolerance. So it's the tolerance for network partition. So system continues to operate despite the nodes being dropped by the issue between the network between nodes. So for example, if you have a few nodes that drop and you cannot communicate with those nodes, the partition tolerance means that other nodes should continue to to operate and to perform, even though the whole network is not connected, because well, not connected, but some node cannot be communicate. And the reason is because in the system you need to have like all the node message to answer you, to see like which is the update that they have at the latest, and whether the node have the latest update. uh, in this partition tolerance, it mean in this regard, in that it said that it's all right to have the weak consistency. Remember, weak consistency, that means like some node is not updated, is fall out of communication, and it's okay for partition tolerance. So you guys all right in this so far? So we will talk more on the consistency. So before we go into another node. So remember, most of the distributed system built on the AP method, so availability and partition tolerance. So the core of distributed system is that it has to be available, and it's all right if we cannot connect to some node. But then sometimes depends on your purpose. For like when you do the bank transaction, then maybe availability and consistency is more important, because you need to have like the update record throughout your system. Okay, so let's talk about consistency. So what is the consistency? So consistency property mean that once the data is written to the database system successfully, so the data will be consistent throughout all of the views. So when consistency concern arrive, when it's tasked to replication and caching, and replication and caching for performance are widely used for scaling technique. So Brian, when you gonna do interview with uh, companies like Facebook, for example, then there will be a section where they will ask you on the scaling technique. So remember on this, on talking about replication and caching. Okay, so for replication, adding replicas improve scalability, but it incurs the overhead of keeping replicas up to date. And I'll talk a little bit on replication. So why do we need replication? So we can have backup in case of failure, and so that we can ensure the availability and reliability. So to keep replicas consistent, we generally need to ensure that all conflict operations are done in the same order and across the server. And this is why I mentioned about the time clock, and why I mentioned about the consistency, because it's still a challenge. Because if you want to scale a system, then you need to accept a certain inconsistency in that. So let's talk about a consistency model. So basically, consistency model is a contract between processes and a data store, which can and if you read some of the slides in the, for example, university presentation, they will divide it in data-centric consistency model and client-centric consistency model. In here, like where you can see like different like sequence consistency, quick consistency, and things like linear consistency. But for this class today, we will just talk more about some of the related terms that you could see on the exam, which is the strong consistency model, weak consistency, and very, very important, eventual consistency. This one for sure you will see that in the CosmoDB. So pay attention to this one. And I just want to highlight that this term is not only specific to Azure database. Wherever you go to NoSQL or non-relational database, this will be relevant. Okay, so let me open an article that I have written. DP200. Okay. Feel free to have questions if you guys have any doubts so far on this. Let me see where sorry. Let me see where I wrote about this, because sometimes when I talk a little bit too fast. So it's good to have something that take a look on. Ooh, where did I put my consistency model? Let's see. Okay, so I just want to highlight here that the more strict consistency, the harder it to scale. So let's talk a little bit about what is strong consistency and what is weak consistency. And I'm talking about strong consistency models and weak consistency models. So strong consistency, that means once there's no synchronized scheme or synchronized construction, because operations shared on the data are all synchronized to one another. So after the update, all the subsequent process will return to the most updated values. So there is no inconsistency window overlap. So that's the contrast of weak consistency, that the system does not guarantee the most updated value. And there's an inconsistency window. And once the update is happened, then you have the consistent data. Right, so with strong consistency, the node will wait and will answer, and once the node is perform the update, then data will be unlocked. And with consistency, it doesn't care about that. And that's why we have the concept of eventually consistency. So eventual consistency meant that eventually all access will return to the last updated value. That means that it's accept that the data is not the latest data, but eventually the system will catch up, and it will catch up with the rest of the other node. So that is what the eventual consistency means. Okay, so let's go back to our slide, and we have a few more minutes only. So let's talk very quickly about HDFS and hbase. And the next section, I will talk a little bit quickly about Spark, because it's important for us to know about Spark for the part of Databricks. In the Azure exam, we will have two parts that will test on Spark, which is Databricks, and HD Insights, which is also built on top of hdfs, and is similar to Azure Databricks. Okay, so this is the pictures about Spark context, which is like how the Spark system is built. And most of the distributed system is built on top of the HDFS HBase. So before I talk any further, let's talk about HDFS and HBase first, and what is the difference. So to talk about that, we need to see about Hadoop first. So Hadoop was created in early 2005 by two guys that worked in Yahoo at that time. And the purpose of them to build a system is for search engine. But then by 2006, developers found out that the distributed file system and MapReduce, by the way, is not built by Doug Cutting and Michael Caffarella. It was a product of Google. So thanks Google for that. So not a distributed file system and MapReduce can be used in many other fields than just for search engine. So uh, that's where Hadoop starts. And Hadoop framework give us the ability to manage, distribute computing and storage easily. And by it, it divides documents across several stores and blocks, store and blocks across the cluster. So you can see it in here that in each of the node, we will have the data that that by split tables and store different data across the node. And you can see more in this architecture also. So we have a client, so we have us, sitting on this machine, and then we send the signal or message to driver, and the driver will distribute it to the executor where they process our data. So for us, for normal user, the system appear to be uniform, but then behind it, there's a different distributing of data across node and the name node. So let's talk a little bit about the Hadoop file system. So HDFS, as you see in here, you see HDFS is the Hadoop distributed file system, and it's a distributed file system that store data on common hard drive and provide access to large amount of application data run on two daemon. So remember this because this could be tested for sure in the exam. So it's one is called name node, and another one is called the data node. And why we always have the backup node for name node? It's because the name node store the metadata where all data is of all the data metadata is stored in data node. So basically name node is like yellow page. You guys all know yellow page, right? In the olden day where we like have to open the book and see like, which phone number is belong to his shop, for example, in the olden day, where we need to look up like Starbucks phone number. There's no option of like Google it out. You need to open the yellow page and look up for that. So it's similar to the name book. So name book, sorry, name node. So node is acts as a pointer. It points us to where the data is stored. So it's very, very important for you guys to have the backup of the name node, because if the name node go down and you guys don't have the backup, then the whole instance is unreachable. And I meant by like everything here is unreachable because there's no pointer to point to where the message should go and query out the data. So that is the importance of the backup node for the name node. And the data node is responsible for read and write requests from the file system and client. uh, and it creates things like block creation, deletion, replication, So that is the purpose of the data node. And you don't have the backup of the data node as you see, because all the data is already backed up in the different node, and the data is divided in different node. So if one node is failed, you still have data in the three others that you can query from. Okay, so let's go to hbase. So hbase is the open source and it's column-oriented database. So remember where we talk about column-oriented, and keep in mind that. So it sits on top of the HDFS, and it provides quick random access to a good amount of unstructured data. So, and it's also leverage the fault tolerance that provide to HDFS. So HBase is a part of Hadoop ecosystem that provide read, write, and access in real time for Hadoop file system. So that is the difference. Okay, and I think we don't have time to go through spec. We can go through it in the next session. So for now, do you guys have any questions on this? We can. Oh, hello, Ravi. Didn't know you
Yeah.
here. You guys,
Yeah. Sorry for late.
that's all right. That's all right. You got. Uh, you follow the session, all right?
Yeah. Yeah. Yeah.
Okay. I'll also have the record later on too, so you guys can read the record. Sorry, you guys can watch the record later on.
Yeah.
So
Yeah.
just to summarize before we leave, so today we go through three main concepts. We go through row columnar oriented, which is very important for understand because it's the key difference between the relational and non-relational database. We also discuss about distributed data store, the different model, acid and base, and we go to CAP theorem, which is the fundamental theorem of distributed system. And I just want to remind you guys again that most of the distributed system built on availability and partition tolerance, and with consistency is all right in distributed system because it allows for scalability and two method for scaling. And this is the questions that ask a lot in when you apply for FANG companies. So how you scale the system? So remember about caching and replica, and I'll have a look some more on whether caching will be relevant in the data engineer exam. If not, we will leave it later on. But caching is also very important when you work with distributed system. So I'll leave that one later on if we have some more time after our session, because there's so many different type of catch and depends on your policies whether you want more secure or less secure with some of the catching. And we go over consistency on the distributed system, and we also go through over some architecture of how to process big data technologies like Hadoop, and we will go for Spark in next session along with security. Okay, so that's it for the session today, guys. I'll leave a few minutes for questions, and if not, we can all log off and enjoy our weekend.
Yeah. It was a nice session. So I'll go through with the recording. If I have any questions, so I'll reach out to you again.
Okay, no worry.
Thank you.
Okay, so seems like we don't have any questions so far. So let's log off. And
Yeah.
the next session we will go against Spark and security, and then and after that we will start to talk on the Azure specific stack. So Ravi, I'll mention with you again on this because we have in a lot of the data engineer certification is not on Azure, but like all other I have looked, and they all requires a specific knowledge in data engineer. So that's why I now separate the data engineer concept out, so that everyone have the same basic level of data engineer concept, and then after that we can move to specific stack like Azure, so that like even if you don't study specifically for Azure, you can still use this knowledge and apply it to other certification on like AWS, GCP for this also. So that's why I am now not talking about Azure yet, but I will after the next session. So, all right, I think that's it for today. Have a good weekend, guys, and see you guys next week. Next week will be a tough topic because we will start talking about different security methods, and we talk about Spark. Okay, so bye bye, guys.
Yeah.
Have a good
Thank you.
weekend.